or the sound could be linked to specific frames, which is another feature that is kind of missing on many engines. And I like the fact that as we're writing everything ourselves, if you want a sound to be played when you lift your right foot, like exactly on that frame, we can play exactly on that frame, because we know when we transition, and there are hooks in the code to say, okay, this is happening, play the sound.
Hello everyone, welcome to the Game Engineering Podcast. Today I am joined by Ali Motisi, who runs Out of the Bit Studio. We discuss their most recent game, Full Void, and we dive deep into their custom engine written in C programming language. If you want to know how to make games from scratch, understand why would you ever make your own file format for graphics, or how to structure your code so that it remains flexible, this episode is just for you. Enjoy. Let's talk about Full Void then a little bit. Tell me about the game. Let's make a little bit of overview what the game is about before we dive into like technicalities.
Of course. So Full Void. Well, let's start. Ever since I tried Prince of Persia on my Amiga 500, I was a big fan of cinematic puzzle platformer. Then I also loved Another World on the Amiga and Flashback, Old World on the PlayStation. So Full Void is a cinematic puzzle platformer. It sits in the same category as those classic games, but it tells a different story. It tells a story of a young teenager alone in a near future where a rogue AI has taken control of everything. There is a mystery to solve. You basically play is very, very immediate, easy to pick up cinematic puzzle platformer. And you work your way through the story, their flashback. There is no text or dialogues, so you basically puzzle the story together as you play. And yeah, the game is not super long. We are aiming at doing like something like a good film or a comic book, something that you play until the end. Hopefully most people will reach the end and connect all the dots and enjoy the story.
Yeah, I like the game that the game was short, the game length. It helped me to like stay in the mood and like not to lose track of things. And I've gone through the game in a single beating, like single time. I sat down and worked through the game. So this helped me. Like it's quite rare now to do smaller games. Like everybody's trying to pack the content and extend it a lot. And yeah, it's Full Void is a 2D game with pixelated graphics, right?
Yeah, correct.
Yeah, and you get to do a bit of puzzling and platforming in the game, and it's cinematic. Like, how would you distinct the cinematic part in terms of like platformer? How it would be different?
Well, especially since we decided not to put any text or voice dialogue in the game. The story is told by cinematic actions, like I don't know, you get somewhere and then something chasing you and you have to react quickly, and there is a sequence of events that unfold that like we kind of know as a game designer. It's like you're part of a film, right? Stuff happens and you're the main protagonist and you have to react quickly. So that's what makes it cinematic. Another thing to add, you obviously mentioned, is pixel art. It's standard definition pixel art. And it's also a game which is good for the entire family. The game is a bit horror, but there is never violence or gore, so you can play together with your kids or whoever doesn't enjoy violence. The game will give you a bit of jump scare, but still enjoyable, but pretty much at anyone, any age.
Yeah. And should we talk about what the game is dedicated? Who the game is dedicated to?
Well, I wouldn't say that
Okay.
because that's at the end. It's the only text that we got in the game, which is at the end. So I would not say that.
That this is the time when I realized that the game is no dialogue. Like the story went through and you kind of absorbed it. And just now I realized that there was no text to read in the game.
Yeah.
Okay.
It makes it more accessible, like in any language, or even like a young kid that can't read, like 4 years old, they can still enjoy the game together with the family.
Yeah. And this game was made in a custom engine, and this is
correct.
We'll probably spend a lot of time in this episode discussing this. So tell me a little bit more about why why custom engine? Why not to pick Unity
Yeah.
or something else to do it?
So, very good question. Well, first of all, I'm kind of old school, so that's what I like to do. When I started programming, there were no engines, so you kind of did everything from scratch.
When did you start?
My first computer was a BBC Micro clone made by Olivetti, and it came with a guide to program a BBC Basic with a bit of assembler as well. And basically, you will just learn to do everything from scratch. That's what you do at the time, right? So I was 8, and pick up the guide and started reading, typing the programs, and see what worked, and then changing them, and then making my own kind of games. Also, there were at the time magazines where you could copy like listings, and which most of the time would have some typo, and then you'll have to fix them. And that's part of the process, right? How you learn as well. So again, when I started, there were no engines. I'd say the most important reason for me nowadays is that I want my games and the games we develop out of the bit to be timeless. I want to be able to build and run my games 20 years from now. A bit like Doom. If you look at the original Doom, right, it runs everywhere. It's written in C, and it's been open source back in the day. Now it's been ported pretty much anywhere. But same with Wolfenstein as well. So I kind of want the game. I don't want to be tied to an engine. Engine grows and fall, right?
Yeah.
So with engine, you have sometimes they're successful for 10 years, and then something happens, a badly managed, and then they go away. And they invested all your source code into the engine, and then what do you do at that point, right? So there's the issue. So the main reason for me to be really free from constraint. Also, I like to own the entire stack. I know how things work. For a programmer like me, there is nothing worse than doing something, hitting a wall where you want to do something and you're fighting the engine. I don't want to be in that situation. Again, as I grew up in a world where you did everything from scratch and I know how to do it, I kind of prefer to be free. If I got a bug, it's my own and I can fix it. So that's the long answer. But the short answer is that I want the games to be independent, and like if I want to open the source code in 10 years or 5 years or next year, I can do it, and people can port the games everywhere, and that's nice.
Yeah, and the porting games, especially Doom, is like a game in and of itself, right? Like to
Yeah.
make sure that Doom runs everywhere. It's not like there's
insane.
A community to which does this. And do you think that making full void in your custom engine took you more time than developing it in a established engine, or on the contrary, because you knew what you were doing and you knew the engine beforehand, because you didn't write an engine from scratch for this game, right? It was a leftover that improved upon with different kinds of games, different games you've developed as out of the bit.
Correct. Yeah, you're 100% correct. I can give you a very straight answer on this one. It took me less time than using a third-party engine, no doubt, without a shadow of a doubt. The reason is, like you explained, the engine, I already developed the engine for Super Arcade Racing and football, and then I kept improving the engine. But even for those games, the fact that the engine is so simple to use, again, I know how to use it because I made it. So for me, it's very straightforward. I had zero time spent fiddling with the engine. I just focus on the game, and the engine does its job, and that's it. So no doubt, I didn't have to deal with the updating the engine and running the project, having different version of the engine for different platform. Like none of that. It actually, for me, I'm not saying this is true for everyone, right? In our case, for our 2D pixel games, our engine is the right choice, and it saves us a ton of time.
Okay.
No doubt.
Okay. How much time did it take to develop Full Void?
Start to finish, it took 2 years development. So
okay,
which I'm quite happy with, to be fair. Yeah.
And also, like, Full Void has a lot of art. So
yes.
In terms of like when we're discussing how much time in terms of development, like programming features, I would assume that a lot of time went into just art and making sure that art is there for
absolutely. The top, in terms of percentage of time spent, the top two items will be art and level design iterations. So those are the two main areas. The engine was like a little bit of that, because it's mostly iterating on the level. Okay, we like gameplay wise, and then art wise. One difference that Full Void we got in Full Void compared to classic games is that pretty much every screen, if not every screen, is custom made. It's not reused and made out of tiles. It's drawn from scratch with its own perspective and items. So it's like a painting on its own. It's got hundreds of screens. So that's what took longest.
And it's beautiful. It's super
Oh, thank you.
moody. It's super moody, and like the vibe, the tone of the game. There's like horror tone. Maybe not horror tone. It's not like it's a horror game, but it's like this feeling when something creeps up a little bit and you feel like unease and like
Okay. Credit to the artist, Miles, Leo, and Tom for the art. They've done a fantastic job.
Okay, and this engine is written in C, which is also interesting because like C++ would be the go-to kind of language in terms of game development. So tell me a little bit more about why C, why C++.
That's a very good point. I use C++ for ages, and in fact, our mobile games at Out of the Bit are pretty much all of them made in a different engine that we made in C++. It worked well. The problem with time, I kind of noticed that when you do object-oriented programming for a small project, it's a bit of overkill. That's my opinion, because you start creating objects for every little details, stuff, item. You start dividing the UI into item. It's good that this is a technical podcast, so I have no problem going technical. Most podcasts have to refrain, but it's a game engineering podcast, so it's in the name. So when you do object-oriented programming, right, you split stuff into items quite often. You got a hierarchy, and then you got an object that it's a subclass of a and you got this hierarchy, and you use, and then everything you want to do is a different class. You want to create a new UI item, it's a different class, and you end up with hundreds of files, hundreds of getters and setters. To be fair, it's a bit of overkill, and for a small project or something you use internally, which is not a third-party API, it means you end up spending most of your time doing setters and getters and creating class and files, and also building takes longer because the compiler has to aggregate all those classes and stuff. So when it came to develop games, so as a company, we started with simpler mobile games, and we slowly tackled more complex projects like Super Arcade Racing, Football, and Full Void. And when it came to develop the games like Football and Racing, they were also available on PC. The first game we made cross-platform. I said, no, I'm going to create a different engine. There's too much in our C++ engine. There are too many classes. There's too much going on. And we've got shaders, and we've got it's too messy. If you want to port the engine to a different platform, you have to do way too many things. So I said, you know what, I'm going to go back to C, which was my original love of programming. Again, I spent quite a bit of time doing C++, Java, C# as well. And going back to C was like drinking fresh water again, like something like that. You just focus on what you want to build. And so I shifted more towards structured programming rather object-oriented. And I never looked back. I'm so much more efficient with it. It's basically 100% of my time is spent writing the code that tells the computer what to do, not managing the hierarchy. The other problem with object-oriented is that quite often you start building these abstractions, right? So you start your project, okay, I think I'm going to need a controller model. Oh, the view will be like that. This will be the hierarchy. Then you start writing your code, and then you say, but now I want to do this, which is kind of an exception. So you start hacking your system to support a new feature that is cross hierarchy, right? And that happened to me, a lot. Like one of our most successful mobile games is called Planet Quest. It's a rhythm game. It's a lovely game. I love the game. And at some point that we had the idea of coming up with a level where you zoom the planet and you got like an infinite canvas of zoom, and then the planet inside the planet is the same as the previous one. It's a bit of a strange feature, but that's what we wanted for our game. And that went completely against the hierarchy that I created for Planet Quest. It was a massive pain to do it. I found a way. It's not pretty. It works well. It's stable. But it's one example of where, okay, you start with an initial concept or how your game is structured, and then you end up with a different, you want to do something different, you're fighting your hierarchy. While in C, if you program in a more structured way, you write what the computer should do. It's a list of operations that a computer should do. And using an approach that is called semantic compression, you start seeing the common patterns and you put them in common functions. And the code naturally kind of flows towards some kind of order that makes sense and is the right abstraction. If you want to know more about this, you can follow Casey Muratori. He's done a Handmade Hero, which is, I'm sure you're familiar with the series on YouTube, where he creates a game from scratch and he goes through similar ideas. So again, why C is the same reason why Casey Muratori is using it for Handmade Hero. And also, again, for me, it makes how you can focus on the game, not on the abstraction. So you want to create that sometimes you do it too soon and then you fight them for the rest of the project.
Yeah, Casey Muratori is mentioned, I think, once every 2 episodes at least at this.
Amazing. Yes, that's good.
Podcast.
It should be.
It's like a lot of people who end up dissatisfied with the, let's say, state of the programming. Let's say the common state of the programming nowadays. They someone drive towards like find Casey Muratori's Handmade Hero and start from there, building up their own mental models, how things can be done. And it's interesting. Like, I think I would agree with this. A lot of the games, even, you can see that they are now written in these concepts in mind, that there are objects, and this forces this structure and architecture of objects forces also gameplay to behave this way. Like you mentioned, you can't have like a wacky transitions even between like planets. If you created an architecture and you are made sure that this planet only controls this part and this planet controls this part, and now they have no way of interacting together because you just spent like hours making sure they won't interact. And
exactly.
This is like putting a lot of constraints on what you can do. And I feel you can see it in games now. If you have like, especially the strategic games, there are systems that are so isolated from one another that it's difficult to imagine they're flowing through. Like rendering is so, let's say, separated from gameplay that you don't have a lot of tricks from going through rendering to gameplay, because it's just so separated and so different in this build in this like separated way. Okay, so tell me a little bit more about the engine and how does it look like in terms of features? Like, what is there in the engine? Because this is also maybe for the listeners, it might be interesting. Like, if you think about the engine, you kind of feel, if you think and you know Unity or Unreal, you're thinking about this list of features that is there, and in order to make my game I would need to recreate everything, and I think it's not the case, right? You want to have the features that you want to have in game, and this is the minimum, the subset that you need, and it will be like 1% of the features that is in the engine, and all of the other parts that you don't use inside the engine, they will still be there to slow you down, to make your UI complicated, the editor complicated, and things like that. So tell me, what features are there in the? Do you have a name for the engine?
Yeah, the engine is called Cereal Box. We always name our stuff like food theme, like Waffle is our mod player, for instance, and Cereal Box is the engine.
Okay, so what features are in the Cereal Box?
Okay, Cereal Box starts as a very minimal C engine. The way to look at it is like, imagine a little emulation box, a little like virtual machine, which is not virtual because it's native in C and everything. But imagine like there is this world where you got two functions pretty much. One is called update graphics. The other one is called update audio. And they give you, the graphic will give you a graphic buffer where you draw with the size of the original screen. And the update audio will give you a frame buffer, audio frame buffer where you write audio. So that's the bare minimum. Of course, the engine supports, like you're asking what are the features. In those functions, it will give you the inputs and the outputs of this virtual machine, which is again not virtual. So it's my way to separate the engine from the platform. Okay. So the game just wants to know that here is the buffer. Please update the graphic. Here is the input. I will give you an array with the number of joypads connected and the data for the joypads. It supports pen input as well, which we use for some custom editors we got. It supports touch as well, which works across Windows and mobile phones for the few games that cross-platform with mobile as well. So we'll give you an array of inputs. Again, joypad, pen, mouse, touch as well, a keyboard, and that way you know what's happening in this virtual machine, which is, again, I'd say virtual, but it's not virtual, it's the actual. But as far as the game is concerned, that's what I get, is the input. And we give you an output, which is where to write the buffer for the screen. And the same for the audio, just how many frames or audio do we need? And then the game will just provide. So it's super simple. In terms of other features, slowly over time, we added common, it's very modular Cereal Box, so you can start with that, and that's it. It will give you update graphic, update audio. The rest is up to you. But of course, we got common extras that we can import and use in the form of header or C files, which are, as I mentioned previously, we got a mod player that we wrote in-house. For people that don't know, mod music is a music format that was very popular in the 90s, especially on computers like the Commodore Amiga. It's got 4 channels of track, audio. It's basically trackers music. So it goes through the timeline, it plays samples with different options. It's very, very efficient, very compact. And the reason we're using it is that we haven't got any musician in-house out of it. We commission the music, and having a common file format is helpful. At the end, I want our games to be very fast to load, like instant basically, and not take too much memory. So mod is a good choice. Plus, with the advantage of giving people that retro nostalgia vibe when they hear the type of sounds. So it was very easy to put an ad on some of the popular mod music forums out there, because the internet is great. There are lots of forums and stuff like that, and find people that are happy to get music on commission. Nowadays, we mostly rely on Robin Powell. She's been fantastic. She's done all the soundtracks for Full Void, and she's working our next project as well. So mod music player, other features, we have developed our own custom file format for graphic, which is very, very efficient. It can do, is specifically designed for pixel art, so it can compress large animation using very, very, very little memory, and it can uncompress them and draw them in real time. So that's something we got as an extra utility in Cereal Box, which is really helpful, as we got hundreds, if not thousands, of animations in Full Void. So that really helps to keep the game small. And then you can play sounds like WAV file as well, which we also have a format. Another one is a voxel drawing. Full Void is entirely 2D in pixel art, but we do have some 3D models which are made in voxel, and they're rendered by the engine in the same pixel buffer. So it's all software rendered. So for instance, if you see the lift in Full Void, stuff that goes up and down, we wanted this to change with the perspective of the screen. And our pixel artist was very good with voxel model. So he drew the voxel model in Cubicle, and then I wrote a custom exporter to export the model into our own format and import and render it in Full Void. So there is a bit of software render 3D, which makes the game a bit cyberpunk. You must have seen it in the hacking games, or when in the programming games, in the games, there are 3D models as well. So that's all 3D by software rendered.
Okay. This is so cool. Like you have your own format for the images, for the graphics. You have the mod player for sound, and you sometimes for the game you're using 3D models that are voxels, and they are converted using software renderer to 2D images to represent. Okay, that's so cool. And when you're saying that that you as a developer are given the buffer to update in terms of the visuals and then the music, the audio buffer, you're saying that this happens per frame, right?
Correct.
Okay, so you're running in a loop, obviously, and per frame you can modify what is being played or what is being visualized, and you, as an input, you get the input from the input devices. So, depending on where the platform, you get different kinds of inputs. Okay, this is so minimalistic. I love it.
Yeah, but it works really well. It's extremely fast, and so together with the update graphic, you get a delta time, so you know how much time has passed from the previous frame. And if you got like a ball bouncing on the screen, you can compute the distance.
Yes.
Things should be.
Do you use physics in Full Void?
Not much in football. We use physics in football and racing.
Yeah.
Supercade Footballer has got in-house custom physics. Is actually the game is 2D, but the physics are 3D because we still take into account the the ball, like the height of the ball as well. It's a football game, so even though the perspective of the game is completely 2D, it's good to have a physics in 3D because it gives the game more realism.
Yeah, but for the Full Void, this is also like even things like physics you don't really necessarily need depending on your game. So
exactly,
Full Void is a platformer, so you would kind of maybe think that this is the requirement, but actually, if you're doing the platformer, you want to grab to the platforms, and you can easily say how the curve or the jump will look like. You don't really need to do a lot of physics in terms of physics objects colliding and computing where they would go after the collision, because it's kind of predefined.
Exactly. Plus, physics can be a pain to tweak sometimes. If you want something you want to control in terms like platformer, they need to be repeatable. People need to know what they're doing, right? So sometimes using physics is overkill. And my advice would be, again, if you know how to do physics, it's fine. Like I've done engineering, so I can implement a physics engine. But sometimes my experience is that it's a bit overkill, and actually then you fight your physics, right? So sometimes it's better to cheat and fake stuff a bit. What's the result that you want, right? Just put it there so it looks good, it's consistent, and you can control it. So that would be my advice. The other thing, as you mentioned in Full Void, another unique feature of Full Void is that you don't see it, but the game is grid-based. So there is a grid of 16 by 9 tiles, which are 20 by 20 pixels. So the resolution is 320 by 180 in Full Void, standard low resolution. The reason is 180, so it's a 16 by 9 ratio, basically, modern display. So you can scale up to Full HD or 4K perfectly, and 720 as well. On the Switch, for instance, there is no interpolation. The pixels are like 1 to 1 or 3. So they look as integer pixels. So that's something we did. So if you aim at 320 by 180, you're sure to upscale correctly everywhere if you want to do standard resolution pixel art. Okay. So I don't like when pixel art is interpolated, it's all like wobbling. Yeah. So that's one of the goals. So coming back to the grid, there is an advantage of having the grid, is that we play animations. And the reason it's not physics-based is that our character will go from A to B within each animation, and we know exactly where A is and where B is. So if it goes up one tile, we know it's going up 20 pixels, and then 20 maybe horizontally if there is a step up, right? So we can bake in the animation, and all the engine does is play this animation now. Let's say you're next to a step and you go up. The player will climb the step, and there will be 20 pixels to the right and 20 pixels up, for instance. So we know exactly where we go from A to B, and we go back to the idle position of the player. So we can connect all the animation, and that's what also makes the game cinematic. We connect all the animation, like from A to B. Every time you play, we play a different animation. So there is no need for physics, and all the animation are like handmade to give the effect that we want in terms of the timing of the animation itself, which we couldn't do with physics. Physics is great if you do like a football or a pinball game. Absolutely, use physics. Like there is no, that's the right way to do it. Other things, it's just best to fake it and have the result that you want.
So did I get that correctly? So for example, if I'm before the block and I would like to go up on the block, I would press a button, and then the engine will get the event that I want to climb the rock. So first of all, there will be trigger of the animation for the character. So the pixels within this one block 20 by 20 will change, like the actual sprite of the character. And also it will be moved up and down. So by the end of the animation, we know that we are one block up and one block to the right.
Correct.
And it's predictable. Like always at the same time.
In fact, that we had, as far as we know, we have zero bug with this in Full Void. It's like the game is 100% reliable, rock solid. You had no issues with it because again, once we test, we go from A to B, and we are again in idle on B, the same position, relative position to the next tile. Then we know it works, and you can do the next animation. And if you jump, we know you will either make it or not, and we know exactly where you are. And then people can. This makes the game a bit different from other games. It's closer to Prince of Persia, but it makes it very, very predictable when you play, which is nice. Like you develop a relationship with the game, and then you get to know what the character can and can't do as well.
Okay. And while running in the loop, there are places where you can allocate memory, right, for the different things that happen. So how do you, generally speaking, how do you handle memory in Full Void?
That's a very good point as well. I got zero allocation in Full Void. Everything's done at the beginning of the game, and that's it. There's no memory allocated. So my way around memory allocation is that I just don't do it. So I preload everything, and that's it. And then it stays there. And since the game is only like 40 megabytes, and to be fair, more than half of this is audio that I didn't have the time to compress some audio at the end, so I just left it there. Otherwise, the game would be like 10 megabytes for thousands of animation, thanks to our DPC format, which we use for the compression. And then we just pre-allocate everything, and it just stays there. Let's say we want to draw something. The first time it's drawn will be cached in a local cache, which is pre-allocated as well. And then let's say we draw the same image over and over. It won't be uncompressed again. It will just be there in the cache. We find it and we say draw it again.
When you say in the cache, which cache do you mean?
It's like a graphic. Let's say we want to draw an image, right?
Yeah.
Let's say we got an image of a face, right?
Yeah.
And there are two frames: the face and then the face that winks at you with the eye closed. Okay, so 2 frames. So let's say we say draw face. The first time we need to draw, we say, okay, that's a compressed image, and we call the function, we'll get the pixel, create the image, and then there's like a local cache of 10 images that we can cache, right? Each type of sprite is got its own ID. So we know, okay, sprite face, for instance, we drew it already. We need to draw it again. It's already in the cache. We just draw it again, right? It's a frame buffer.
It's a software cache.
Everything's software, yes. Software, everything is done in software, and then it's rendered at the end. Let's say now we move to frame 2, which is the eye is closed, which is winking, right? So our compression algorithm will find that what's changed, and will only update what's changed in the cache. So we'll find that the image with the face was already in the cache. We'll have to draw the next frame. We'll just draw the differences, and then the cache is ready, will be drawn on screen. So that allows us to have everything compressed, already preloaded, and then it's just uncompressed real time when we need to draw with some caching. So the idea is, again, we don't do any memory allocation. Same goes with audio. We preload everything. It's in memory. When we need to play it, we just access it and play. And that's because the game is small. Of course, you can't do that if your game is 2 gigabytes, right? But nowadays, if it's pixel art, you can probably get away with it.
Yeah. So just like I mentioned, to be fully clear, like this is possible because Full Void is a relatively smaller game. Like things that would be like of the open world Witcher 3 cyberpunk things, like there's no way you can do this because the data you would need to load to the memory would exceed the limits.
Yeah, exactly.
But for the smaller games, you can do it. And this is also the thing, you can do it because you have your own engine. Because in
Yes.
Unity, it wouldn't be really possible to do this, because you would rely on dynamic allocation for all the stuff that you would like to allocate. There would be places where you could do this up front, but still in a dynamic way, because you don't get to manage the memory so directly there.
Yeah, you're right. And to be fair, there are games that are pixel art that are like a gigabyte for no good reason. So just because if you, like you say, if you use the engine, that's the way to do it, and you just end up with lots of like allocation and prefabs and stuff you import, which make the game, still have load times and be much larger. So yes, it's one of the benefits of using the engines. Like the game is tiny. And that's one of the reasons that allow us to be on the Evercade console, because the Evercade is a handheld console that it's got physical cartridges. We were able to port Full Void very easily just because of the low memory requirements and the fact it was written in C. So that sometimes it's an advantage to use your engine, because you can quickly port your engine to a new platform.
Okay, can we talk a little bit about Switch? Because I now realize that I don't know a lot about Switch as a platform.
Yeah.
So
Sure.
You mentioned that in order to have like 60:9 pixelated graphics, that would scale to HD or 4K monitors easily, you would need the proper aspect ratio, so 60:9, and
Correct.
for pixelated, the standard is 320 to 180. Right?
Yes.
And Switch resolution is what exactly?
I think 720 on the screen.
Okay.
And when you connect to the TV, it's full HD.
Okay. And for the Switch development, you need the special kit from Nintendo.
Yes, of course, I can talk about Full. I cannot talk about Nintendo APIs because it's under NDA.
Yes.
So.
Okay.
But yeah, it's really well done.
Okay, so you like
the Switch side.
But in high level, you receive the API, like the software pack. You sign the documents about the NDA, for example, non-disclosure agreements, not to discuss them. But then you're able to develop. Do you pay for this? Do you can say this? Like,
I'm not sure what I can say, but again, it's I will refer people to go to the Nintendo dev portal. Or find a Nintendo representative and talk to them, because again, it's all under NDA. What I can say is, in general, not speaking about Nintendo, but in general, people say quite often, "Oh, using your engine, it will make it difficult to port to consoles and stuff." My experience has been every single console on the planet, the underlying system, guess what language they're using? There is in C, and then everything else has been on top of that. It's been super easy to port, like on Switch, PlayStation, Xbox. It took literally days for the technical part to be done. You find C APIs everywhere, like for audio, for graphics, even on mobile, for the iPhone, for Android. My experience has been C is everywhere. It's like the English of programming languages in a way. You find a way, and it's quite often it's the lowest level nowadays. It's not like the exposed, machine code or anything. So the lowest level nowadays is basically C.
Yeah. How did it look like to create art for the game with the custom engine and custom file format? So how did artists work, and where they would export the files, and how it would connect to the engine?
That's a very good question. So initially, when I created the engine, I also created, to test the engine, I created my own drawing software package, inspired by Deluxe Paint on the Amiga PC, right? So it was very simple to use pen and touch, so you could just use your pen, which was fun to do. Unfortunately, I can't draw, but I had fun creating the software package as a test program for the Box engine. And that was called Dorayaki Paint, so D-Paint. So when we started, our first designer started using our own custom software package. Then he was actually familiar with the Deluxe Paint on the Amiga, because he grew up and worked during the Amiga Mega Drive generation. So that's Dave, and he did the graphic for racing and football. So he was very comfortable with the Deluxe Paint. So he told me, you know what, I got my own copy of Deluxe Paint from back in the day. I can install it and use it. And I said, you know what, I don't care what you use. My approach to artists is they need to use the tools they are comfortable with. If I need a different format, it's my job to write a converter. So that's my approach. I like people use whatever tools they're comfortable and familiar with and efficient. I don't want to force tools on them. So they've used Deluxe Paint to do the graphic, which is a bit funny. It's a classic retro program at this point. He did the graphic for football racing and part of Full Void as well on Deluxe Paint. And then I exported the image as PNGs. And then I got my own converter from PNG to our own file format, which again supports compression as well and animation. So I'll give you an example. Let's say there is a one frame only. I just convert the PNG. Let's say it's a long animation, like a walking cycle, right? It will export the PNG as a PNG strip, which is a PNG where each frame is next to each other, right? So let's say it's got 2 frames and the image is 10 by 10 pixels. It'll be 20 by 10, so double width because it's 2 frames, okay? So it will be a PNG strip with as many frames as we need. And then I got my own converter, will read the PNG and convert in our own format. So I will find that it will put like a W at the end, like W with the width of each frame. So the program, the converter knows, okay, that's the width of each frame. Therefore, that's the width of the image. There are 10 frames, or 2 frames, whatever. And it will convert the image in our own format. So the artists, they don't need to worry about what I do internally. I can change my own file format if I want to, like create improvements and stuff. And I just have my own converters, which I put in a folder. So that we got a shared folder, they will put the asset in a shared folder. I'll just double tap, the converter will convert all the PNGs into our own DPC custom format, and then I drag and drop that format into the game. Now, I mentioned that the engine loads everything at start. The way we do it, the engine knows every assets, we call them assets. There could be any file that we're importing, right? We'll import, there is a special way to build the engine where we load all the assets and put all them into a cartridge. Again, see, as I like to see Box as its own virtual console hardware, it's got a cartridge. So as if it was a Mega Drive with a cartridge inserted. So all the assets, everything in the game is contained by one file, one cartridge, which is loaded at the start. Everything is slotted into memory in the right place, and then the game can just access to it. So that's how we do it. We convert everything, but obviously as we develop, we keep adding images, sounds, and stuff. So the way to do it, there is a flag. So I can either load and run everything from files as a development mode, or I can just convert everything into the cartridge and then load everything from the cartridge, which also makes it faster to load because it's much easier to access one file. You have one file, read everything, put it, stick it in memory, done. Close the file. I will never access the file system again. That's it, unless for the save data, of course. But in terms of assets, they're all in one cartridge. And again, my approach is to use the tools I want and I just convert them. So custom converters for images and for voxel models. And mod music is just, we just use it the way it is.
Okay. So the only convention that you have is to put at the end of the file W and the number, and this allows you to automatically know per file how much width the given frame has, and you obviously know what is the full width of the file, so you can split it in frames. And you
Correct.
have both. And you have both animation and graphics inside this one file from an artist then.
Correct. Yes. The W is optional. If there is no W, it means the image is just as is. It's one frame. If we find the W, it means there could be more than one frame.
Okay.
Depending on the W.
Okay.
W stands for width, of course.
Yeah, I like these like lightweight conventions.
Yeah.
Like, you know, it's obviously, some people may say that it's not optimal because, well, you can make a typo or a mistake and you have some issues, right? But you can put more constraints. For example, I have like more folders or whatever, like do it in any convention. But this is so lightweight, and at some point you're collaborating with the same people. so they know, they learn what
Yes. Yeah.
what is the convention, so they gradually stop making mistakes. Maybe in the beginning they
Yeah.
do, but and at some point the communication is so smooth because of this lightweight, constraint, not so much constrained way of communicating. This is very lovely. This is very nice. Okay.
Yeah,
Okay.
and for the records, the current artists, they use a sprite to do the
Yeah.
graphics, mostly a sprite, and they can export as PNG as well. So for me, there is no change. And you're right, they just need to remember to put the W if it's an animation, but it becomes second nature after a few days that you do it.
Yeah.
So
Yeah.
no problem.
So what about level design? How did you approach this? In the
Okay, so that's really very game specific.
Yeah, maybe we can also split this question into two parts. So one, level design in terms of like game design for Full Void,
Yeah.
and then
Okay.
technically how to make a level and properly make sure that it's split in blocks and things like that.
Cool. Okay, amazing. Let's start with the technical part first, because as I mentioned, it really depends on the game. In the case of racing, we went more like classic approach of tile base. Okay, we got those type of tiles, and like Lego bricks, we can use them to build a level, right? Because racing is a top-down racer, and you got different location. Like you got city, you got I don't know, desert, you got snow sections. What we did for racing, we built our own level editor, which will create its own file format that the game reads and put the level together. And the nice thing about racing is that the level editor was built with the controller in mind. So the game designer could design the level with the controller in hand, then push a button and play the level, push a button, change it. So that's quick iteration cycle is really key, in my opinion, because if the level designer has to build a level, launch the game, and then ask the developer for a change, you would never get. You need to be able to iterate quickly and a lot for games. So again, if the game can be tile-based, I suggest to do a level editor. In the case of Full Void, you'll be surprised to find out that all the levels are baked into the code itself as characters. So if you got a wall, it's like a sharp character. If you got water, it's like tilde, right? So it's got special conversion to create. So you can just look at the level, and it's like looking at the matrix. Now we literally look at the matrix and say, okay, that's the section where you got a bridge, and you got special letters for objects that have an action, like something that can break. So they're all baked into the level. So technical point of view, again, we got a mix depending on the game of level editor. Full Void is all baked into the game because I took care of the level design together with the guys, but it's there and it's super quick to change and launch. I can still make changes and rebuild with a live loop and see changes live in the code. So that's nice. From the game design point of view, again, the key is iteration, and especially like any game really, you need to be able to make changes and play the game quickly. So what we did with Full Void was we sketched it out on paper first. Let's say the sewer section in Full Void, where you go down the sewers. We went to the pub and said, okay, what do we want to achieve with this level? We want players to feel a bit lost, like they're in a labyrinth or something. They don't know where to go. They know that something bad could happen. We want a good reverb in the audio, so we want a spatial position in the audio, which is handled by the engine itself. In terms, that's very simple to do. We got a reverb function as well that can process sounds to make them feel like you're in a room or something. There's quite lightweight filters that you can find and how to do it online nowadays. There are also good books. There's one, I don't remember the name, which explain audio in detail in C, which is fantastic. If you look it up on the internet, I'm sure you can find it. Anyway, so in terms of level, yeah, it's the key is iteration. So we sketched them out on paper and then we put them as blocks. So I got a special mode in the game where I can launch the game and see the grid and see the tiles. We posted some images in our Twitter feed where you can see this. And we play the level with the grid first. We make sure that the platforming works. and then we put graphics on top of it once we're happy. And then of course we still make changes, because then you say, oh, maybe we like this section, we can do more of it, or this doesn't quite work, and we change it. So then we got our family of friends to test the level, and we see straight away what works, what doesn't work, and then we go back and tweak it. It's all about game development. It's all about iteration. It's the key phrase here, the key word.
And in the full void, when you have this like as a ASCII, let's say, signs and characters, you have a character for, let's say, a background or like a wall. If you switch from sewers to the city, you have a different type of tile, or you have different ASCII characters for each kind of, background and things like that.
Good question. There is a character we put, which is kind of is the background, right? Quite often is the character 0. We put it on the top left, and that character will say load background, and then there is hook in the game which will say, okay, I need the background, and the code will say, okay, look, your level 1, screen 3, that's a background you're going to load.
Okay.
Yes.
So you even have this. So it's super cool, because you have now, you don't really care in terms of the characters in the for the background. You don't care. You know that it's a background. So for your human mind, when you're seeing this, you know that this is going to be background, and the computer is the one who is deciding, okay, this one, because we're on this level. So it's good background, the proper background when you run the game, but you don't need to worry and have mental model of each different background based on the ASCII characters. This is so nice. I like this. Like, everything is so thought out, so thought out to make sure it's minimalistic, simple to understand, and like easy to use. This is so cool.
Even that, it's not like it was planned. It's just the result of iteration. Okay, what can we do to we always do. We do a meeting at the end of the week, and we say, what can we do to improve what we're doing, right? I'll give you an example on point. The other week, we're creating a new game now, which is similar to Full Void. We have not announced it yet. It's not a sequel though, and but it is similar in terms of it's got screens and stuff. And we were always moving a special character to be where the player spawns, because we built the level. Let's say we're working on the last section. We don't want to start from the beginning, so we got special checkpoints and stuff. And Leo suggested, why don't you put a special mode where you can just specify what room or screen you want to start, and the code just does it for you. So, that's a good point, because we keep moving this W character everywhere. And I did it. It's so great, because it's saying, I gave you a new screen 120, and I can just put 120 and the character will spawn on that screen. And it's just an example of, okay, it's not that like we thought about this at the beginning. It's like, it's a result. Okay, where can we remove friction? And that's a really good tool, like for any developer. Look at what you're doing. If you're, another example, if you're switching between mouse and keyboard too much, that's friction. Try put some shortcuts. You shouldn't switch too much. Also, it's not good for the shoulder. So anything you can do to improve like iteration cycle, you should do it. It's worked because it's multiplied, right? And it's the same for this. We're minimalistic, and sometimes certain things are big, like very simple, or just they look very, very not fancy, I'd say, but they work. They're very efficient, and they work for us. Again, we're a small team. We're only like 4 or 5 of us, so we've got to be efficient. It's important.
You do game design meetings in a pub. You mentioned that we were
sometimes we go to a pub, we play pool, or we go to a coffee shop. In summer, we like to go to a local coffee shop in Wimbledon. Nice. We get local discounts, so it's good.
Nice. Tell me a little bit more, because about the cutscenes. So Full Void has this place where you obviously do the gameplay parts, but also they're interweaved with the cutscenes in between. So how cutscenes are made in the engine?
Okay. Again, cutscenes are just an instance of our DPC format, which stands for Dorayaki Paint Compressed format. And it's just an animation. Our tool is designed to really compress, and it's like a lot more efficient than PNG, and it's got no compression artifacts. It's like lossless quality. So it's, you can reproduce the original image with the original colors. And the guys will just create the animation. with a sprite quite often. They also can use proper animation programs like TV Paint and stuff like that. And then, yeah, they just export the PNG and I put in the game, and I got a special code in the game to say show full screen animation, which will play the animation on top of everything else. Quite often can associate sounds together with the animation. In the sound engine, I put some code to say, okay, do it reverb or not, spatial position on left and right, and also potentially there could be a delay when we play the sound. Or the sound could be linked to specific frames, which is another feature that is kind of missing on many engines. And I like the fact that as we're writing everything ourselves, if you want a sound to be played when you lift your right foot, like exactly on that frame, we can play exactly on that frame because we know when we transition, and there are hooks in the code to say, okay, this is happening, play the sound, and everything connects nicely. And we can do that for the full screen sequences as well. Let's say you got a sequence where you do something and something happens, we can say, okay, at this frame or when there is this special marker, play this sound. So it's like you create a cartoon, right? You got images and you want sounds to go along with it. And it could be one big sound that you play at the beginning of the sequence. It could be smaller sounds that you play when a specific marker is found in the animation. I'll be more specific. We got our own convention, especially for full voice, since everything was so dark. We use a full pink dot, full color pink dot in specific places. If we put it at the top left corner of the animation, it's a marker, and then we can divide the animation in chunks. We can say if chunk 1 is when the character does this, and then chunk 2 is when it does something else. And then we can use that as a hook for sounds or to connect with other animation or to break into different animations. Another special instance of pink dot is one that we put. Let's say you got a long run cycle. One thing that we like to do in our games, I kind of hate when games slide when they walk and the walk is not connected with the feet, if you know what I mean. So we take care, that's why many people say, is the game rotoscope? Is it, which is technique used in the past, like Prince of Persia and stuff. And I say, no, it's hand animated because the artists are like really good. But it still looks rotoscope because the feet follow the ground. So the play is anchored to the ground. But at that point, you got another problem. It's like, how do you know? How does the game and the engine know where the character is? Let's say you're chased by a wolf or something, and the run cycle goes from A to B, and B is like 120 pixels away from you, right? It's just an image for the engine. How do you know when you collide with it, right? There are different ways to solve this problem. A very simple way is ask the artist to put a pink dot at the bottom of the feet of the character. The pink dot will never be drawn. As we got our own palette swap, when we draw a sprite, all the colors are indexed. So we can say, pink dot, you don't exist, you're transparent, right? There is no cost to this one. But the engine knows, I can ask on each frame that you're drawing, where will the pink dot be? And then I know how to do a collision. Again, very simple, it's not elegant, it works very well, it's super efficient.
It's great also in small teams, right? I can imagine like if you grew the team to 100 people, the conventions with pink dots in files or things like that, it will become messy. But that's great, like to have conventions and tools and mechanics in your own company suited for your needs, right? And you can save so much time with such conventions, right?
Totally.
Yeah, and in Full Void there is this cool effect, the CRT effect, when you can increase the intensity of the CRT effect with the slider or with the modes, just like increase harder, more intense.
Yes.
Can you tell me a little bit more how it's made? Because I don't think I've seen the proper CRT monitor in my life. I only see the software effects in the visuals.
I can't say the same. I grew up with CRTs there. I don't know how I managed to see anything, to be fair. But they got their own beauty because sometimes they render things. I mean, if you play an Amiga game or Mega Drive, Super Nintendo, they are designed for CRTs. So in a way, they look best there. Nowadays, of course, you got filters. And the reason is if you got low resolution pixel art and you got like a 50 inches screen, the pixels are going to be big. Sometimes I don't mind, I like seeing the pixels myself, but I can see how that could be off-putting if they're like massive, right? So CRT filter is a nice way to have that effect on the screen. There are many ways to do it. You can be really aggressive. What we ended up with is still the game and the software rendering doing it. There is no specific shaders. The way I done it, I went to study how filters work and how I can approximate them. It's not perfect, but it gives a good, a good approximation of CRT. So I rendered the game at higher resolution. So the game is still rendered 320 by 180, okay? But the buffer that I use, so Serialbox can tell, Serialbox knows the actual display and the resolution of the native display. Let's say I'm running the game on a TV at 1080, right? Full HD. Serialbox knows that. He knows that the regional screen is 1080, 1920 by 1080. And he knows that the game is 320 by 180, right? So it can decide to render the game like use, I don't know, 3 pixels for each pixel. We will pick something higher, right? There is a rule there in the CRT filter. And then it will look at rows, whether they're odd and even, and it will use slightly different color conversion for each value of RGB. So for each pixel that we need to draw, right? We know where we are, we get the color, and this is all done with lookup tables because you don't want to do any computation per pixel. So anything you do on a frame buffer per pixel needs to be super fast. So what I do, I pre-compute all the color conversion. So for each value of R, G, and B, depending if you're even or odd rows, right? I do a different color conversion. So if I find, I don't know, R where is red, green, blue, so RGB are red, green, blue color components. So let's say you're in row number 0 and red should be 255. I use a lookup table and red becomes 215, for instance, right? There is another color conversion for blue, another one for green. And it's different depending if you're odd or even, rows or columns. So it ends up with a different, like, it kind of simulates the fact that they're individual like pixels. They're a bit separated, and it creates a smooth like transition between them, giving the effect of a blur CRT filter. I went through many iterations. I think at the end I toned it down a little bit for performances, but it's one of the things I got in my head. If I go back to it, I think I can improve it a bit more even. But the result is quite okay, so I don't want to tamper with it. But I think it's something that if I have another crack, I can do even better. Like, I think it's one of those things you learn. The more you do it, the better you get at learning and improving. Yeah. So I think I can do slightly different color conversions, but maybe I'll tweak it in the future. I don't know, but it's okay for now.
Okay. So the lookup table is there per color, right?
Correct. Per component, yeah.
Per color component, right? So for red and green and blue, so there are 3. And depending on whether you're on the odd or the even row, you use different ones. So there are 6.
Yes. Correct.
Okay. Nice. I didn't know.
We went really technical there. Okay.
Yeah.
I'm having fun because I don't do that in any other podcast. So it's good. We need more technical podcasts. I always love when they go technical podcasts because you learn stuff. But I understand it's off-putting for people that are not technical.
Yes. But
if you listen to game engineering podcasts,
Yeah, this is exactly. Like, this is, for me, I crave such things. Like, it's not easy to find even on the internet. Like at GTC, it was once like that, but it more diverted into more like business oriented talks from games. Sometimes. And it's less and less common for people to talk about these things. So this is why there's a game engineering podcast where you can discuss like that there are different components for each pixel and how you can tweak them, and whether you want to do it on a fragment shader on the GPU, or you want to do it in a software and the CPU directly. And while you're mentioning lookup tables in order to be efficient, quick because you can't really do a lot of operations per pixel also in software like CPU part, because this is very intensive. So like yeah. And do you have problems with performance on full void some places, or
No, it runs everywhere. It runs on the Nintendo Switch, 60 frames per second. It runs. I got one trick. I got a very old laptop, which is Atom CPU, like single core CPU, and I use that because it's my travel laptop. It's super lightweight. I know it's not fast, as I got lots of memory. It's slow, but if the game runs on that one 60 frames per second, it's pretty sure to run anywhere on 60 frames per second. So I use it as a baseline. I always test on my laptop. Yeah, it's my benchmark. I make sure, because again, if you've got a single core CPU and it can handle audio and graphics software render real time, 60 FPS with no audio cracking, then you know it works everywhere.
Nice. I wanted to ask you about the engine in terms of like the editor. So if you have like a Unity engine, you're kind of using Unity editor. So you have like a standalone app that is visual, where you have menus and you can drag and drop things. And if you start from scratch, there's no editor. Like if you want an editor, you need to build one. So did you build an editor for serial or not really?
No, there's no idea for CR box. It's just again, we got a level editor for racing, which is specific to that game. And yeah, it's all code pretty much. There is no editor. Yeah, sometimes it's good, but my problem with editors, they also come with a way of doing things, and I like to keep my options open. Like the editor will assume certain stuff, and then you start from the same point, and games become semi. Sometimes they're similar because they start from the same premise or the same way of doing things. I just want Gearbox to be very open. It's like old school. Here is the memory. It's pretty much that's the memory for the graphic. That's the memory for the audio. That's the input. There you go. You're on your own. And yes, we do collect utilities over time because we don't. If we need to display an animation, there's probably some code we already written for it. But again, let's say we're making a new game and we want to do something different. We are not forced to use that code. We can do something else.
Yeah, and it's easy to tweak also. Like you just don't call the function, you create your own function.
Exactly.
Okay. And which tools do you use to develop the code for it? Visual Studio?
Okay, so yeah, Full Void was entirely made on Windows. On my main editor was Windows with Visual Studio. Works great. We support live loops as well, so we got debug mode where we build everything as a DLL, and then we can rebuild it, making changes. So let's say I'm working on football, and I'm working on the goalkeeper of football, and I score a goal, right? And I think the keeper should have gotten the ball. Instead, the ball went in. I can press a button and I do a live loop of like 5 seconds. So the action will replay in the game, and I can change the code for the keeper, see why he didn't get the ball, debug, put breakpoint, and then change the code, debug again, and making sure that the keeper will grab the ball or not, or push the ball away. So it's another tool which is really good in terms of iteration, because sometimes, especially for real-time games, you want to see, sometimes you don't manage to reproduce a problem, or you want to see why something happens. The ability to push the button, enter the loop, and then change the code is really, really like valuable. So that's what we're doing. So that's for Full Void. You'll be surprised to know that recently I moved to Linux with Visual Studio Code. I also develop on Windows as well, so it's a mix. But mostly my daily driver at the moment is Kubuntu Linux with Visual Studio Code, which is open source as well. And the reason is I like the fact that it's quite modular. So with Visual Studio Code, you can create your CMake file, which tells, okay, that's where I need to build the project, all the defines and stuff like that. And then you import your CMake in Visual Studio Code, your C file, and you can just build it. And I support as well on Linux, live loop as well with dynamic libraries, and it's super, super fast. I'm very happy with this setup. The reason I did it is because I wanted to have a native port of Full Void on Steam Deck, right? So I said, okay, I'm going to look into it. And also Rafael, which is the other developer out a bit, he helps with porting and maintenance. He did the initial porting to Linux. And as I wanted to be able to make change myself and stuff, I hadn't used Linux in a long time. I said, okay, I'll take the opportunity to do some Steam Deck development and I'll try again Linux. And I loved it. It's so good. I ended up switching to it. Like everything's super fast. It works well. I'm very surprised with the level of polish. KDE, the desktop environment, now it's so good, so fast. Like everything works well. And Visual Studio Code, I know there are other editors, but that's the beauty with Linux of something, a code base which is not dependent on a third-party engine. You can change your setup. So if I get fed up with Visual Studio or they make it bad, it's really good at the moment. Let's say they make it bad in the future, I can switch to something else, which would probably use CMake as well and build a game. So that's great. So I ended up working a little bit on the porting for Steam Deck, and then I loved it so much that it stuck with me. So now my daily driver is a little like Linux box,
Nice.
which is connected to my mouse and keyboard, and it's super fast, super efficient.
And just to mention, for all the listeners who may not be inclined, know a lot about C, like usually for the programming languages, you have programming language and the compiler interpreter is one part, but there's also tools, right, to make the program. And in C, you can have a C compiler, which is capable of compiling a bunch of C files. But as your project grows, you need something to kind of make this into a project abstraction. And this is where CMake and then make tools come into place, right? So apart from writing C files, you write CMake files in order to tell, okay, these files go together and they create this library, and this is a static library or this is a dynamic library, and all these things are controlled through CMake. And anything to add on this?
Yeah, you're spot on.
Okay.
Yeah, very, very good explanation and context there. CO Box is so simple, you can actually build from just command line or a script. CMake just makes it more convenient to. It's like there's a CMakes list file, something like that.
Yeah.
It's a text file where you just say, okay, those are the files, those are the libraries, and you can have conditions as well. So let's say you got the debug mode or the release mode or the mode that creates a cartridge for the game. It just makes it handy. But you could do with just command line or command line scripts as well. It's just nicer to use CMake.
CMake becomes much more helpful if you're integrating with a lot of libraries. And
yes,
because in C/C++ world, it's a little bit of a mess, like compared to for example, like newer ecosystems like Python or JavaScript. You have like a standard registry where you have like a predefined package what constitutes a library, and in C/C++ you usually need to like understand the library first in order to know what to do with it and how to compile it. And a lot of libraries in C world have CMake lists with them. So when you're running on CMake, you can just say, okay, I am going to provide you with the source code of the library here. Compile it, please, using this CMake. Bye-bye. It's
correct.
It's much easier.
Yeah, correct. To be fair, in C, you haven't got a lot of, like, in our case at least, the only library we're using is a Steam library to do achievements and stuff. The rest is just custom code in C. There is no third-party dependencies. But quite often, depending what you're doing, you might want to integrate other libraries as well.
And in terms of the Steam Deck development, I think I don't get how it's connecting to the Linux world. Can you tell me a little bit more about that?
Of course, Steam Deck comes with Linux installed. The version you find, I think it's a Ubuntu Linux distribution, right? But they use KDE as a desktop environment. There is a lot of information there. Okay. So Ubuntu is one of their main Linux distribution.
Okay.
So Linux comes in different shapes and forms. Ubuntu, I think, is the most popular. And I think that's why Valve chose it to put it there. It's widely supported everywhere. On top of Ubuntu, you can put different desktop environments.
Yeah.
It's the way you move Windows and stuff. I know you know this stuff. It's just for context. KDE is one of the best. So that's what they put there. There's GNOME as well. And so what they advise from the official Valve website, which I think is public domain, is to develop on Ubuntu because it's got the same libraries as the Steam Deck. So if your dev environment runs in Ubuntu, and your game runs in Ubuntu, your game will run on the Steam Deck.
Oh, okay.
Pretty much. You still have to test, of course, and make sure it's fine. But that's what they advise. And to be fair, it's a great advice because Ubuntu, you can just find anything you need and help online as well. The Linux community is great for forums and like help in general.
Linux community, maybe not Linux community, but like Linux in terms of like Ubuntu, at least for the last like 20 years, they made such a drastic change.
Yes.
I remember and like recall reading stuff that was older than 20 years. It was incomprehensible. But at this point, if you like, it's as easy to use as Windows. So if you're used to Windows, you can install Ubuntu. And I'm usually working on Unix platforms anyway, either through macOS or Linux in terms of development. So game development is tricky to do. It's maybe not tricky to switch. It kind of depends on what are you using. Like if you're using an engine, like Linux support, for example, for Unity is not, there is something, but it's not really good at this point. So, but if you're using just C engine, custom engine like you, and you could just need to get the compiler, which is I think by default GCC there on Ubuntu, right?
Yeah, absolutely. If you got an old computer, an old Mac, which is not supported, or PC, I advise you to install Linux and give it a shot because it's gone a long way now. And not every profession can get away with using Linux, like you mentioned. Depending what you're doing, your program might not be there. But if you're a developer, there's a good chance you can use Linux, and it's a really great setup.
Okay. Looking back at the Full Void development, what would you say were the biggest challenges from the game?
In general, the biggest challenge working on a team is working with a team. In general, it's not so much in the end. I mean, we are a pretty good team and we work really, really well together. So no problems there. But in general, it's like that's where a lot of iteration discussion goes, to be on the same page, which is good. But it's also exciting to work with other people in a small team. Is what I prefer. That's why I'm not growing the company on purpose. I like to develop one project at a time, keep the team small. Many business people, investors, tell me, you should grow the company, you should really expand, take investor money and expand the company. I don't enjoy it. I don't want to. I want to have a small group of people doing stuff they love with passion, and that's it. It's like a handcrafted shop. I don't want to become a factory. That's best. If people want to get investor money and grow the company, that's great. Good for them as well. It's just depending. You need to enjoy what you do, I think. But in terms of technical side difficulties, no, I really enjoy. It's one of the best development experience I had as a project. Full Void. I enjoyed every minute of it. One of the advantages, I stay away from online play and leaderboard, which I've done with the football racing, which was great. But I kind of enjoy working a single player game. Okay, that's it. That's the game. Again, update graphic, update audio. That's experience for you. It's all self-contained, can be ported anywhere. You don't need the internet. You don't need microtransactions. You don't need that. So you can just enjoy the game, and that's it. So that was fun. It was fun to do. We had, I have to say, it was one of the best experiences. I had zero issues with compilers or code or anything like that. So,
okay. What kind of advice would you have for people starting out in this field that would like to do it more from scratch?
Yeah. Top advice is keep it small and keep it simple. Like, don't try to do GTA if you are like 4 people. Don't try to do League of Legends. Like, try to keep it simple. Don't do a massive multiplayer game, and do many small projects. That's why we've done lots of mobile games before, like 20 mobile games before approaching more complex projects. Do something original, maybe do a smaller project, keep it original, but not too original, because then it could become difficult. Make sure you test the game with friends, because you got an idea, you know how the game works, and then as soon as someone plays the game, you'll see how it works, if it works at all. They do something you don't expect. So again, keep it simple, enjoy the process, and remove anything that gives you friction. Just keep an eye, have a weekly meeting, say, how did the week go? What can we improve? And we are forced to pick one thing to improve. For instance, recently was the fact that, okay, at the end of the day, we got to put the graphic assets in a shared folder. We got a shared folder, but sometimes, people forget to maybe upload them, and then they go on a holiday and we can access the image. For instance, that's a stupid example, but it's an example, right? That's an example of a problem. So do a weekly meeting and say, what can we improve? Do we spend too much time launching the game? Do we need to change the compiler? Is there something we're doing which is wrong? Can we do a live loop? Can we iterate on the level design quickly? Remove friction. That would be my top advice. And I don't plan the game in details at the beginning, because you will change your mind. When you start the game, this happens 100% of the time for every project we work on. We start with an idea, and then as soon as we start implementing the game, we say, but we like this more. We actually like to do this in the game. Not what we like is not what we thought we were going to like. And that changes the game design. So do design it loosely, but then keep your options open to change your mind. That would be my advice. Of course, if you manage to plan it and it works 100% the way you plan it, great. My experience is that doesn't happen quite often. You change your mind as you progress, as you should, because you iterate on it. It's like when you write something, an essay in English, right? You write it, then you read it, and then you change it, then you show it to people, then they point out that they don't understand what you're saying, and you change it again. So it's that process there. It's the same.
Okay.
So keep it small and iterate on it.
Okay, that's a lovely advice. Thanks so much for talking to me. Maybe then can you tell me where people can follow you, follow your work out of the bit?
Sure, my pleasure. I always like to geek out on technical stuff, as you've seen, and I'm happy to do it on Twitter as well. X, Twitter, whatever it's called nowadays. You can follow the company Out of the Bit, like BIT, Out of the Bit. Same on YouTube. We're going to have a big announcement coming up next month on YouTube. And then myself, I'm also on Twitter /X as Ali Motisi, just Ali Motisi, name and surname, one word. And then the company is also on TikTok as Out of the Bit Games, but we are not using TikTok much. We are not sure how to use it yet. A little bit. And we're also on Instagram as Out of the Bit. Just
we'll
like
put
that.
the links.
So,
put the links
yeah,
in the description.
top choice for me will be Twitter and YouTube.
Okay.
I mean Instagram as well, but
okay.
Keep an eye. Keep an eye.
And on Steam to buy Full Void. That's where people
Absolutely.
can find.
Great. We are on discount at the moment, and we do discount regularly. So keep an eye. Wishlist the game Full Void into Steam. The game is also available on Evercade on physical release, as I mentioned. It's also available on Xbox and PlayStation 4 and 5 and Nintendo Switch. Did I mention that? Yeah. So everywhere, basically. Pick your consoles and wishlist Full Void now.
Thank you. Thank you so much for talking to me. This was lovely.
Anytime. My pleasure.